So the next session is on motorized pulley, energy efficient solution for bulk material conveying systems. And in this session, we'll hear from Hagenau, Product and Export Manager, and Deepak Bhandari, Country Manager at Rulmeca. Mr. Hagenau, I request you to please turn on your video.
Thank you.
Yeah. Thank you for joining us.
First, I would like to share my screen.
Yeah, I'll briefly introduce you to the delegates first, and then we'll start with the presentation. Mr. Hagenau is Product and Export Manager at Rulmeca. Currently, in addition to training his colleagues on site, he supports Rulmeca India Private Limited in setting up the infrastructure for nationwide sales and services for the products, including local assembly of motors, especially for the Indian market. He is mechanical engineer from Technical University in Magdeburg, Germany. Thank you for joining us, sir. You can start with the presentation now.
Okay, good. Okay, thank you. Good afternoon, ladies and gentlemen. As introduced, my name is Jens Hagenau. I'm working for the Rulmeca Group as the product manager for motorized pulleys and for heavy-duty rollers. And today I want to speak a little bit about our products and how our products can help to improve the ecological footprint of a company, means how to make operation more efficient. First, some introduction of the company, then I will talk about a little bit about the product and some types of or some ways of monitoring our systems. Rulmeca is a global operating group of companies specialized in providing components for the materials handling market in the world. That means we are a pure component manufacturer and supplier. We don't make any conveyors or full applications. We are focusing 100% on the components. So we have long time experience in this business, working globally with 1,200 people in 17 companies worldwide. Here in Germany, this factory started in the middle of the 19th century, producing machine parts and components. And with this long history, we started in the 1950s to develop a product, what we call motorized pulley. What is a product what is a conveyor drive, and this conveyor drive, in this conveyor drive, all the components of a drive, that means electric motor, gearbox, all this is combined into a fully integrated device. For the bulk materials handling market, we make this from a diameter 220 millimeters up to 1000 millimeter, and with a power from 0.5 kilowatt up to 250 kilowatts. It is a totally enclosed system, quick and easy to install, and it is a product focusing on niche of the market where all the benefits, all the advantages, the features of the product can help an operator of a factory to improve the performance. I will go a little bit to keep the 20 minutes a little bit fast through my presentation. If required afterwards, I can share a PDF version of this so that you can review later also this presentation and the details. So we are with a motorized pulley, we are replacing where it matches the requirements of the application. we are replacing conventional drives where we have the electric motor, where we have a coupling, a gearbox, clutch, pulley, pillow block bearings, support frame. All these single components we replace with one integrated device where we have also an electrical motor inside, we have a gearbox inside, we have a pulley, and all this is electrical connected here through this hollow shaft to the electric grid. So, and this design makes it to a very simple and very resistant and efficient drive. All these components, motor, gearbox, and the connection to the pulley, all this is directly connected. There is no coupling inside, no extra coupling inside. That means in case, especially for bigger motors, for bigger powers, in case that there is a smooth start required, the starting will be provided by the electronics. That means by a frequency converter or maybe a kind of soft starter. This is not realized by any specific coupling. The motorized pulley is running in the moving parts inside of the pulley are running in oil. So this oil has two functions. As for any gearbox, of course, is lubrication of the parts. And here for the motorized pulley, it is also important that the oil is helping to transmit the heat, what is created through the electric motor, by the gearbox, to help to bring this heat to the shell, and via the shell, the heat will dissipate to the environment. That means when the motor is running, the oil will be by such a shovel here. The oil will be shoveled up to the top position, and then it is running here through the wiring, and it's running here through the gears to make a proper cooling and lubrication of the system. The big advantage of this design is that we have a good sealing of the system. So when you compare this with a conventional drive, then you have here, you see here pillow block bearings. You have two sides with sealing. On each side, you have the input and the output of the gearbox, the output of the electric motor, maybe also the side where the fan and the cooling of the electric motor is. So this is a lot of, let's say, access points where the environment, dirt, dust, any chemical materials, water, whatever, can have an impact on the system. With a motorized pulley, we bring this number of access points down to 2. And just by the mathematical view, the chance of a breakdown is here lower, and it makes the system quite more reliable. And these specific points we have according to the needs of the application, of the environment of the application. We have different types of sealing, so that we can choose here the best sealing, what can resist the external environment. So can be a standard sealing for simple application, can be a labyrinth seal, or also a regreasable labyrinth seal, what is covering the inside of the motor where all the components are, makes this very good protected against the environment. The system is also a good solution in terms of safety, and that means that all rotating parts, all fast rotating parts, are inside of the drum. From the outside, just the drum is rotating, and of of course, driving the belt, but all the other parts, what you have here, what is brackets, and also here the connection area for the electrical connection, all these parts are not moving, they are fixed. So that in total, it is a very safe solution. There is no rotating coupling, no rotating shafts where you need extra guards and extra equipment to improve the safety. Another point, what makes a motorized pulley for a lot of solutions very brings a very good advantage to such solution is that we have as the center of the weight almost in the middle of the system. That means when a classic drive with a gear motor on one side is bringing a big torque into the steel construction. That means for designing a new machine with a gearbox on one side, you need to design the steel constructor stronger. You need to have extra features to resist this torque. And with a motorized pulley, you bring this center of gravity more or less in the middle, not 100%, but more or less in the middle of the system, what makes it easier to use it in conveyors, maybe here like such mobile screening machines, but also in stackers, reclaimers, all these machines where there's a boom conveyor, what is supported by ropes or any steel construction, helps, the motorized pulley helps to make the design easier and also more cost efficient. The reliability of a motorized pulley comes from the system itself. When seeing a motorized pulley, here is a picture on a test stand, and this runs with a conveyor. Then you see that the cooling works very simple and very stable. So that means we have the carry side and the return side of the belt. And when the belt is driving and is running and it is in contact with the motorized pulley, then you have a small delta of the temperature between the carry side and the return side of the belt. This delta, depending on the power of the motors, depending on the speed of the belt and the environmental temperature, but this delta is something between 4, 5, 6 Kelvin, and this is after the start. This is a constant value. This becomes a constant value, and this constant value is providing a proper and constant heat dissipation. That means we are totally independent from cooling ribs, from fans, or any external cooling device. What can be influenced by dirt, by dust, whatever. So that means when the belt, the conveyor is running and the belt is running, then there is a proper cooling of the motorized pulley. And this is a very stable process and runs very, very reliable. Some notes to the, some remarks to the efficiency. We know, or we have learned from the past, that 20, 30 years ago, it was very common to use or to design drives with extra power. So that means the calculated power requirement of a conveyor is maybe 50 kilowatt, and then the choice was to use a 75 or 90 kilowatt drive, just to have some safety into the system. Basically, I can understand this behavior. Today, I must say, it becomes more and more unpopular, because the point is that when you have between the required power and the nominal power, there is a big gap. Then the system, the electrical system, the electrical motor becomes very inefficient. So that means that the cosinus phi value of the system goes down, and the system becomes more and more inefficient. So when keeping this gap as small as possible, then it is possible also to run the drive, run the electric motor close to the optimum. That means the motor runs on a more efficient level, than having this big gap. So from our point of view, when we are working with customers and creating new proposals for drives, we are discussing this very, very detailed, and try always to convince to have the motor close to the real power requirement of the system. And even there is a short overload of the system, then we can say that even, let's say, a 50 kilowatt motor or a 55 kilowatt motor with a nominal required power of 50 kilowatt is able also in a short time to provide 58 or 60 or 62 kilowatt. So maybe if there is some overload because of specific reasons, even a 55 kilowatt motor can provide this more power, more required power for a short time. And there is, from our point of view, no need to go up to 75 kilowatt just to feel better. Let's say to feel better, to be on the safe side. This is also the reason why we are mainly working with motors in the high efficiency and premium efficiency class. We at the moment we avoid to make motors with the super premium efficiency, because we see here significant higher costs, and finally, because most of the motors are running in this not optimum range of the power requirement, that they are finally not that efficient as expected, just from the super premium efficiency. So to make this running of a motorized pulley safe, we are just in a phase of finalizing development for the Rulmeca monitoring system. That means for motorized pulleys, we are doing here, we are establishing here a system what is measuring the temperature inside of the motor. So means this is already available. We can measure the temperature inside of the motor, and here we can see from the normal run of the motor, there is a motor specific curve of the temperature, and here easily we can see deviations, what gives us the information that there could be something wrong in the inside of the motor, or maybe there is something wrong with the load of the conveyor permanently. So the second point is to using to checking the amperage of the motor. What is the current? Also, there are normal values, and here we can also see very good if something has happened when the current, when the amperes, when there's a too big deviation. The next step will be then the vibration analysis, where we have then sensors in the motorized pulleys for measuring the vibrations. This is today so there are so detailed analyses available that you can just with 1 or 2 sensors, you can measure or you can monitor the whole system, all the bearings you have inside of the motor, and you can exactly say what bearing is maybe out of the normal range. What type of failure? Is it a failure on the outer ring of the bearing? Is it on the inner ring of the bearing? Is it the bolts or the cylinders in the bearing? This is possible today, and yeah, we are just on the way to integrate this. And I think from next year we will also provide such vibration analysis to the market. These are just some pics from such measuring the amperes. These are the vibration sensors. Here in this case, it is outside of the motorized pulleys, but you can also bring the smaller sensors. You can bring inside of the motorized pulleys to have these data permanently available. Rulmeca will then provide a system, what is not just a sensor. We will also provide a gateway and a cloud application where these data are stored, and we will also provide the data processing so that finally the data will be checked, and we can give you, or the software, the data processing software can give you an answer if everything is okay, and or if you have to do something in preventive maintenance to avoid any bigger problems later. Yeah, so as a simple solution, it will give you on the control room of your factory, it will give you a green, a yellow, and a red lamp. Yeah, so what means green? Everything is okay. Yellow, you have to check or you have to look into the data in detail, and red, of course, then it's quite late when something is something serious is happening. So something similar, just to mention this here, it will be for the what we are doing is for the idler, because a conveyor is not just the drive, it's also the idler. Yeah, we will bring in here a system what should help to make rollers of let's say red line conveyors, very important conveyors, conveyors what have a significant importance for your whole production, for your whole factory, to make this conveyors permanently visible in your control room, or to help to make conveyors visible in inaccessible areas, where you cannot send people to these areas, maybe in tunnels where there's a lot of dust and dirt in, so that you cannot permanently send in people there. So in such areas, this system makes the roller visible. Just to give you an idea, what we want to solve as a problem. Here, this is a accident of a conveyor in South America, where some blocked rollers they created some overheating, and then after a certain time, this conveyor starts to burn. And in this case, I think this was a steel core belt ST 4500. I don't need to mention how expensive it is to change a little part of this belt, with all these belt splicing, and what high costs are this. So the system will work in this way, that there will be a sensor in each roller. The sensor at the moment is measuring the temperature of the bearing, and the roller is saying the roller is running or not. So it means the temperature of the bearing gives you an indication of higher resistance, of maybe a bearing failure, of maybe also overload of the conveyor. when the load is higher than the designed load, also this can lead to higher temperatures in the bearings. And the second point is also very important. It tells you if the roller is running or it is standing still. If one roller is blocked in the system because of a stone or of any reason, and the belt is sliding over this stopped roller, so then the shell will be damaged. You will have very, very sharp edges, what can finally damage the belt. So that this system can help you to avoid unscheduled stops. It can avoid consequential damages. So that means if one roller fails, then you will not replace this roller in a short time, then it can come to consequential damages that the next rollers are also impacted by this damage, and more than this one roller can fail very, very soon. And of course, belt damages should also be avoided by this system. And the point is, of course, it is a cost issue. You can save there a lot of cost for unplanned downtimes. You can reduce your spare parts, your volume of spare parts you need to maintain the conveyor, and also this helps, let's say, to have a better balance of your ecological footprint. So we can do this worldwide with all the frequencies of the long-range wide area network in the different countries, so that this system will be available worldwide. The same, the sensor and the wireless gateway will collect the data on the conveyor and send this to the data processing in the cloud. And via a web interface, you can see exactly the place where the roller is, the number of the roller, and this makes your system much more safe in such critical areas. So finally, here Rulmeca wants to provide this as an extra service to their components. We are working here in globally in a lot of countries worldwide. So, and our focus is here to give our customers a very good service. Even in India, we have started in end of 2019, I think. We have started our operation in the first point with some service. And here we will improve this also to some kind of local production in the near future. It's a little bit depending on the pandemic. So, but this is the plan also to grow in India and to provide sufficient service in India as well for our customers. So, thank you very much.
Thank you, Mr. Hagenau, for a very insightful presentation. We'll just take a few questions that have come in from the delegates.
Yeah.
So the first question is, what capacity of conveyor this type of motorized pulley can be used for? And what is the lifespan?
Yeah, this is the point is, I said at the beginning, we are limited in power. We are doing motors with a power of maximum 250 kilowatt. Because we have with this motor some physical limits. That means all the heat what we are creating with the electric motor and the gear inside needs to be dissipated through the shell. So that means there are some limitations. So that we, until today, we have not planned to increase the power exceeding this 250 kilowatt. And also the power is always a little bit related to the diameter, but means for small motors, let's say a 220 diameter, they have a maximum power of 7.5 kilowatt. The same related to the surface of this motor, but for a bigger motor, let's say 160, 200, 250 kilowatt, then the diameter is 1000, just for having the bigger surface. So this is the range what we can provide.
So he also wants to know what difference does it make to the cost?
Is a little bit is a little bit depending on the application. We say, and this is our approach to the market. We don't want to replace any conveyor drive in the world. So that means would be good for us and also to do this, but we are focusing on niche markets. That means when having let's say a boom conveyor of a spreader, then the motor, the drive itself, will be more expensive than a conventional drive. Maybe 10–20%, depending on the manufacturer of the gear motor drive. Maybe also 30% more expensive. But in this case, we don't compare just the motor. We also compare the efforts to make the steel construction stronger for a gear motor, or maybe to use the gear motor at the tail side of the conveyor, just to avoid this extra cost on the head section of the conveyor. But then a drive on the tail side of the conveyor is I think not a good compromise, because the best position for a drive is always the head section of a conveyor. And comparing this on specific applications where we say the motorized pulley is the right product for, I think we will be a bit more expensive for the investment, but we will have higher capex, but the opex finally will be lower because of also lower maintenance costs, lower operational costs.
So another almost a related question: what is the cost advantage versus actual life of motorized pulley? A customer will get what advantages from Rulmeca versus Rulmeca make motorized pulley compared to a normal pulley, so that they pay the extra amount? What are the advantages?
The advantage is this total integrated system. That means that our electric motor, our gears, everything is inside of the motor and is so hermetically sealed and hermetically protected against the environmental influences. So, for example, a gear motor with a coupling in between, you have an electric motor with cooling ribs. At the end of the electric motor, normally there is a fan. So, and all these are features of a classic drive, what can be impacted by the environment. So cooling ribs can be blocked by dust. A fan can be blocked just by a stone. Can be blocked the fan of an electric motor just in this moment. You have a problem with the cooling of the system. So, and with a motorized pulley, it is when the conveyor is running, when the belt is running, then there is the constant cooling of the motorized pulley.
Okay. So the next question is regarding the design safety factor. So what is the general design safety factor percentage that you're taking during engineering?
Yeah, this is different from motor to motor. We have motors they running with quite low safety factors. So let's say between 1.2 and 1.3, because of let's say just of the market needs. These are serial products used always in the same machines. So where we exactly know the requirement, the power requirement of the machine, and the requirement of load overload, underload, and here we can make a specific design what is in terms of cost efficient for the customer building these machines. Yeah. So for specific applications, we have factors in what is 1.4, 1.5, can be more. Yeah, this is a little bit depending on the application, because for the smaller motors with 220, 320, 400 diameter, this is more for us more a business of serial machines. So that means we are making standard machines in high numbers from 500, 630 and bigger motors. This is more an engineering business. That means these motors are engineered for the case. This is nothing what we have in stock, where we just go to the shelf and take one out and send it out. This is something where we have first a very detailed engineering process, and then finally, according to the application of the customer, we make a proposal, and then it will be designed and built according to the requirement of the customer.
Okay. So the next question is, are the pulleys available as standard catalog product, or they are customized? I think you've already answered that the pulleys are customized according to customer requirements. So the next question is, do you have a belt sway sensor?
Excuse me?
Belt sway sensors.
No, I don't think so. When I understand this right, you mean sensors checking the belt. Is it correct?
So maybe the delegate can contact you on the email, and then you can provide him the details.
Yes, please. We can discuss in detail afterwards. Yeah.
So I'll just take the next question. With the motorized pulley, there may be increase in temperature when belt is in contact with the motorized pulley. So can you brief something on this?
Yeah, this is this is a point. When the belt is not in contact with the motorized pulley, then there's no cooling. But then there's also the motorized pulley is just a rotating cylinder. Then it has no function. The function is to drive the belt, and for this it needs to be in contact with the belt, of course. So that's why we say the standard operation for a motorized pulley is as a drive of a belt, as a drive of a conveyor. There are some other applications where motorized pulleys are used, but this is very limited, and this is very specific, where we have to do a lot of analysis before to check the issue of heat dissipation. Yeah, so from our catalog, the products, you should start from the assumption that the motorized pulley is a drive for a belt conveyor.
Okay. So the next question is whether a pulley is designed to take bending load.
Yes, we have. This is the same. We have these values in our catalog. So that means for each size of the motor and for each power and speed, you have specific values for the maximum belt tension, this T1, T2 issue, and also for the maximum torque what we can provide. This in this case, basically these are catalog values, and you can find in our catalog.
Okay. So another question is regarding backstop. So how do we fix backstop to prevent reverse rotation of pulley?
Yeah. All our motorized pulleys can be equipped with a backstop. That means we have a device inside of the pulley equipped to the rotor shaft of the electric motor. So that means at this point in the whole system where you have the lowest torque, the highest speed, but the lowest torque, there is a device, is a backstop connected to this, what makes a proper stop of the conveyor in case of losing electrical connection, so that the conveyor can run back with material to the downhill side So this is available for all our motorized pulleys.
So another question is regarding the cost comparison. So what is the cost comparison between motorized pulley and traditional conveyor pulley drive arrangement?
These are two questions. One question is the capex, the investment, and the investment is for a motorized pulley is higher, in average higher. It's a little bit depending when you compare this to drives like SEW or Siemens Flender. We are more or less on the same level than such drives, yeah? Because you always need to compare not just the drive. You also a gear motor drive is not just the drive. It's the gear motor. It's all the coupling you need, it's the pulley you need, the pillow block bearings you need, and maybe also some extra swing base for the gear motor. Yeah, all these components together you need to compare to a motorized pulley. And for high sophisticated drives, we are more or less in the same range like this. Of course, there are other suppliers focusing on low prices. And then we are more expensive. Yeah, then easily we can be more, let's say 20% more expensive in the investment, in the capex, in the operational cost afterwards. Is it from our point of view lower because you have lower efforts in maintenance? You have lower number of breakdowns because of this totally integrated drive. And I can say we have drives running 15, 20, 25 years. Means when there is a proper installation and a good calculation at the beginning of the project that we really choose that we have chosen the right motor for the application, then it is a very long-lasting solution, and it will also give some money back, some return on investment just on the high lifetime.
All right. So the next question is regarding safety measures. So what are the safety measures has been taken in consideration in case of conveyors moving in reverse direction if power off and failure? I think that you've already answered with the backstop solution, right?
Yeah, it's the backstop. We can also provide brakes to our motors. Yeah, so that means we have also the option to use brakes when you have a motor running on a reversible conveyor. Of course, you can't use a backstop. In this case, we can provide brake solutions. What can be let's say an integrated brake. It can also be some customers preferring having external brake solutions because they want to use the same brake supplier for the whole plant. Then we can also provide a solution to add an external brake, drum brake, disc brake to the motorized pulley.
So the next question is regarding the reversible conveyor. So can motorized pulley be installed with reversible conveyor like boom conveyor and stacker reclaimer?
Yes.
I think you just mentioned about it. So the next question is regarding gears. What type of gears, bearing, and lubricants are being used in your components?
We are. This is, let's say, is a little bit some of the secrets of the long lifetime and the high quality of our motorized pulleys. Most of the gears, all the key components of the gear, we are making in-house. We have our own manufacturing here, making the gears and producing all these components. This is very, very important because we need a high and constant level of quality because these motors are running around the world. So, and a motor from Australia or from Chile, you cannot just bring back to factory for some repair if it is a bigger motor. Yeah, so that means we are depending on reliability, and that's why we keep this in house, and we are not doing this with external suppliers and in low-cost countries, because the problem here is the stability of the quality, to get a really constant quality. And this that's why we do this in-house. And the components, the external components like bearings, we are using here exclusively premium bearings. That means SKF, FAG, and Timken.
Okay. So the next question is regarding bending load. I think we've already discussed it earlier, but I'll still read through the question again. How effective these motorized pulleys are in case of bending load? What is the effect on pulley shaft and inside motor?
Yeah, this is the reason why we say we need really to investigate at the beginning of the project what will be the application, or what is the requirement of the installation. The motor, according to our catalog, has a maximum load what he can accept, and overload can lead to some misalignment inside of the motor in the gears, and can create there some extra wear on the gear rims. So in this case, small metal parts are inside of the motor in the oil. And this is there is a system where we can observe this. So that means we have some magnets in the system what we can screw out from the end disc on the side, and see if there are metal parts. And if there are metal parts, then something is wrong with the tension. But the basic point is we need a very clear and very reliable calculation of the maximum belt tension. And if the belt tension exceeds the capability of a motorized pulley, then it is no solution for this conveyor. So this honestly we need to be.
Okay. So the next question is regarding the motor. What is the difference between IE2 and IE3 motor?
This is first I need to say the motorized pulley is not under the regulation of the IEC standard. The IE1, IE2, 3, 4 says electrical efficiency of an electric motor, and in this case, an electric motor, as you know it, from an external drive. So that means a single electric motor is you can define into categories. Since the motorized pulley is an electric motor, but it is inside of the motorized pulley, direct connected to the gear. And this type of motor, because it's an own design we have, you can't use for any other application, and that's why it is not under the regulation of the IE 1, 2, 3, 4. But you have, in comparison to this, you have standard efficiency, premium, high premium, and superior premium, or something like this. This is just the verbal description of this efficiencies, and according to this, we are working with high and premium efficiency. And we are also able to work with higher efficiencies. That means with, compared to IE4. But in this case, the system becomes incredibly expensive because you need to change everything. And we are limited in space, of course, with a motorized pulley. We cannot increase easily the diameter or the lengths or the gears and this. So that it is adaptable to an IE4 electric motor, and that's why our standard is high-end premium efficiency.
So the next question is regarding the reliability. So how much are these pulleys reliable, and how much time is required to attend to the problem? Do we need to keep spares?
Yeah, this is a very popular question when thinking about a motorized pulley. First is the motorized pulley is because it is an hermetically sealed system. It is in general very reliable. When you are using in a factory motorized pulleys, and of course it is always good to have a spare in stock. We cannot guarantee 100%. We can say maybe this is 99% will run, but this 1% we cannot we cannot manage. When you have a factory with a couple of motors, a lot of motors in, then our proposal is always to make a unification of the drives. So maybe you have 20 drives in, that you make a unification that you have for these 20 drives. This is covered by 3 or 4 types of drive. That means in terms of the size of the motor, the length of the shell, the diameter, so that you have 3, 4, maybe 5 types of motor. And then for 20 motors in operation, you need just to have these 5 types, one of each type you have to keep in stock, or you keep as a spare. This is the way we go.
Okay. So the next question is, what is the backlash value?
Excuse me, the
backlash value. I think maybe the delegate can connect with you on the email in this case. Then we will just, we will take the. What is MFG warranty guarantee in hours of operation of the products?
Our standard warranty is for the motor is 24 months after start of operation. The maximum is 36 months after dispatch from factory. So especially for engineering projects, of course, when the motor is leaving the factory and is arriving 4 weeks later, it will not start immediately. So then there is an installation phase and all this. So that we say, in general, 24 months, but for such engineering projects, we will have this extra rule that we say 24 months after start of operation, and maximum 36 months after commissioning in the conveyor.
So the next question is regarding the maintenance. Is it easy to do maintenance inside motorized pulley?
Let's say, our general headline when selling a motorized pulley is fit it and forget it. So that means normally there should be no maintenance. We recommend to change the oil inside the motor after 50,000 operating hours. 50,000. So that is 50000. This is this is a recommendation mainly coming from the oil supplier. So basically, even after 50,000 hours, if the oil is fine, if the oil is clear, maybe you can use it longer. So that means in the meantime there is no maintenance required. What can be required is when using, because of specific reasons, you are using regreasable labyrinth seals. Then these labyrinths needs to be regreased from time to time. This can be done manually by a maintenance guy, but it can also be, and this is our suggestion, we can do this with greasing cartridges on one on each side. What is doing this job for, let's say, for 6 months, and after 6 months you just need to replace the cartridge with the grease. So this can also be done automatically. So basically, is just to look, when you look in general around the conveyor, what's happened with the conveyor, what's happened with the belt. Of course, you should also have a look at if anything is blocking maybe the motor, or is sliding on the motor. and also the legging of the motor. Doesn't matter if it is rubber legging or it is ceramic legging. That the legging is okay, and then but inside of the motor is no maintenance. Just in case of there is really a major breakdown, then it can be required to open the motor. And in this case, for smaller motors, is not so big issue. For bigger motors, in this case, we recommend to use the support of our maintenance people.
I think, sir, on that note, we'll end the session. I request you to please share your email address in the chat window, because there were a lot of questions, and in case I have missed any, they can contact you on the email.
Okay, fine.
Yeah. Thank you, sir. Thank you for joining us.